All right, that's live. Hello, welcome in. Happy Friday. I hope everyone's doing well. I'm out of practice because I'm only doing this one day a week, so it's kind of rough. But I don't have like 100 people watching, so like I guess it's not that big a deal. But yeah, I'm gonna go ahead and get into it. I am going to go ahead and work an applications problem for systems of linear equations. I'm trying to get off of this topic, but I'm stuck in a point where I'm not sure what to present next. So yeah, I found this problem and yeah, I feel like it's relevant. We are going to be basically writing an equation of a parabola um, using systems of linear equations, which this is kind of new for me. It's a new concept, but uh, very relevant and involving. I liked it because it's involving second degree polynomials, which I absolutely love. Parabolas. I like working with the quadratics. Higher order polynomials, they start getting kind of complicated. Um, I like them too, just not as much as the second degree polynomial. So anyway, I'm glad I found this applications problem, and it's something that I hope that everyone finds relevant as well. So here goes. It says determine the equation of the polynomial passing through the points. It says write the equation of the polynomial passing through the points. One comma 6, 2 comma 3, and 3 comma 2. So this one, what we're gonna do is we're gonna pull out the form for the polynomial. So that's y equals ax squared plus bx plus c. And we're going to use this form, and we're going to write since we have 3 points, we're going to write 3 separate equations. So essentially, we're going to write the first one when x equals 1, y equals 6. So just plugging in x and y here, you're going to get, let's see, that'll be 6 equals, let's see, 1 squared, so it'd be a times 1 squared plus b times, just plugging in, move out of the way so people can see what I'm writing here, plus c. And then simplifying that, you're going to get basically list the coefficient first. So that would just be a plus b plus c. So that'd be your first equation. We'll box it. And then we're going to repeat this process 2 more times with these other 2 points. So when x is 2, sorry, and y is 3 times 2 plus b, 2 squared, don't forget to square it, b times 2 plus c. And just simplify that, so we have 3 equals a, 2 squared is 4, so it's going to be 4a plus 2b plus c. All right, and we'll box that one. That's our second equation. And then we've got one more. 1x is 3. And y is 2. So we've got 2 equals, let's see, a times 3 squared now, plus b times 3 plus c. Simplifying this one finally, 3 squared is 9. So 9a plus 3b plus c. Perfect. All right, so we have these 3 equations and we have 3 unknowns. And what we're going to do is we're just going to make a system here. So we can rewrite this if you like. But this is a plus b plus c equals 6. And this one is 4a plus 2b plus c equals 3. And the last one will have 9a plus 3b plus c equal 2. Perfect. All right, so we have this system. And really, it's not an overly complicated system. It's only 3 variable. I've been working on the ones with 4 variables. So it's just, how do we want to solve this, really? And so I just have to think about it. Do I want to use matrices, or do I want to just solve it using good old-fashioned algebra? Substitution elimination, I haven't thought that far. So I'll just pause and think about how I want to do this. Well, I'm only about 10 minutes in, so I still have plenty of time. If I wanted to try to set up and augment a matrix of coefficients, we could see if we could get that in a couple steps, or I could just, let's see, if I could eliminate. I could eliminate a variable here and just solve it that way. If I just let this first equation like solve for a, and I could plug in a into the other 2 equations, that would probably be the fastest way to solve it. Honestly, that's probably what I should do. So we'll just solve this first one for a. This would be a plus b plus c equal 6. Don't require it. And then, so just subtracting b and c, you're going to get a equal 6 minus b minus c. And so we could box this and then take these other 2 equations and plug in. So this is going to be 4a plus 2b plus c equals 3. So I plug in A, it's going to look like this: 4 times 6 minus B minus C plus 2B plus C equal 3. And so 6 times 4 is 24. And then we have negative 4B minus 4C. Just using that distributive property. Now we're going to combine like terms. So anything alike that we can add. We've got the B's. So it's going to be negative 4B plus 2B is negative 2B. And then minus 4C plus C is negative 3C. And then we're going to subtract 24 from both sides. It's going to give me a negative 21. And then, well, if we multiply everything by a positive 1, it's going to give us 2B plus 3C equal 21. So we'll box that one to stay positive. All right. So let's go ahead and repeat that process for the other equation here and try to just see. Let me see if I can fit it in here at the bottom because I want to preserve this forward space. So to get in. So we got 9 the other way, 9 times. Now just plug in this here, 6 minus B minus C. And then it's plus 3B plus C equal 2. So 9 times 6 is 54 minus 9B minus 9C plus 3B plus C equal 2. So we've got, we're going to subtract 54 from both sides. That's going to give me a negative 52. And then negative 9 and positive 3, that is a negative 6B. And then it looks like minus 8C. And again, we're going to multiply everything by a negative 1. 2 negatives make a positive. So it's going to give me 6B plus 8C equal positive 52. Try to stay positive if I can. All right. So since I have these two equations, I'm going to go ahead and make a little mini subsystem now. So it's going to give me 2B plus 3C equal 21. And I also have 6B plus 8C equal 52. Now, I probably don't want to use substitution in this case because of the fact that when I try to solve anything here for a specific variable, I'm going to deal with fractions. And while fractions are my friend, they you just try to avoid them if you can. You just try to keep things simple. So what I'm going to do is elimination method for this subsystem. I'm going to go ahead and multiply this first one by a negative 3. And then I will eliminate B that way. So I mess up my original system and keep that intact. So I'll just put a little curly brace and repeat it. So if I take negative 3 times 2B plus 3C equal 21, and everything gets multiplied, then I have negative 6b minus 9c equal 63. Negative 63. And then I'm just going to take this other equation and add them now. So I've got negative 6b minus 9c equal negative 63. And then plus 6b plus 8c equal 52. And we'll just add those together. 6 and 6 is 0. Not -1 and +1, that's negative c. And then 63 and 52, that's 11. Negative 11. Let me see my where's my calculator at? Okay, D3, so it'd be 62 would be 10, and then one more would be 11. All right, so we've got two negatives here, so C has to be 11. We're going to box that one, and then we're going to repeat that process. Actually, we have C here. We can go ahead and figure out what B is real quick. So just take that top equation, 2B plus 3 times 11 equal 21. So that's going to be 2b plus 33 equal 21. Subtract 33 from both sides. So that's going to give me 2b equal to be or to not to be. All right. Excuse me. 33 minus 21 is 12. I just want to make sure. Negative 12. So divide off the 2 from both sides, and it's looking like B is negative 6. C is 11, so we can just use this one right here for A. So A equals 6 minus B, which is negative 6, minus C, which is 11, positive 11. 6 plus 6 minus 11, that's 12 minus 11 equal 1. So A must be 1. All right, so how do we write that polynomial? We're just going to take those values for A, B, and C and plug into that form. Right. And then I was hoping to have a little bit of room to graph it. So let's go ahead and write the polynomial using this form. And we have A, B, and C. So we've got y equals A, which is 1, so it's going to be x squared. B is negative 6, so it's going to be minus 6x plus C, which is 11. So here is your polynomial. And then if we wanted to sketch it real quick, I guess we don't have much room for our graph, do we? I want to get back to graphing anyway, so it's a good prelude or whatever it's called. Plus, minus, this is x, y. We have a y-intercept of positive 11. And we know we have a parabola. Let's see. What else do we want to do real quick? we can find x-intercepts, seeing if it factors. Does not factor easily. Do I have my old calculator? Maybe this is my new one. Of course, where is my other calculator? I say my old calculator, I have that quadratic formula plugged in. I can do it real quick. I'm out of board space. Let's see, 24 minutes in. Actually, this is only 20 minutes because I was 4 minutes late. All right. We have the y-intercept. I could go ahead and put it, I could complete the square. I'll put it in vertex form, so we just at least have the vertex. I don't know how much room I have down here to do that, but that involves y equals x squared minus 6x, leave room, plus 11. And then you just take this number, -6, and you have it. And that's -3, and then you square it. That's 9. So it's plus 9. So then we have to minus 9 here. So if you plus and minus the same side, then it doesn't change the value. And then this makes a perfect square of, so be x minus 3 y squared, and then 11 minus 9 is 2. And the form is negative, and that's positive. So your vertex ends up being at, so it's going to be 3, 2. So it's like that too. So we have those 2 points. And I guess if you wanted to just find out what's going on, let's see, 1, 2, 3. Let's see, 3, so 3 more would be, let's see, 1, 2, 3, 1, 2, 3, right here. At 6, then you could just plug in actually. When x equals 6, what's y doing? We got 6 times 6 is 36 minus, oh, it's at 11 as well, so, because it's a symmetrical graph, so just verify it's 6. So we have 36 minus 36 plus 11. So y is 11 again. Good. So there's a real quick sketch of that graph. Yeah, all right. Vertex. You're going to have an axis of symmetry in here. Your axis is going to be at x equals 3. Yeah, just more values. Graphing these parabolas. All right. So I think we'll go ahead and call that good. That was a productive 20 something minutes, almost 30 minutes. But yeah, that's good enough. Sometimes I'm not really feeling live stream, so I have to make sure that I'm showing up regardless. And so it was good. Today was not a good day, but I mean, it was a great day for me, but just not necessarily feeling the math. Anyway, all right, so we'll go ahead and stop there, and I will uh, say thank you for watching my video. And if you have a math question, please don't hesitate. I'm still working on trying to figure the chat out. I actually saw where I have a comment, I just can't see the comment. So um, yeah, hopefully I'll figure that out one of these days. And sooner than later. Anyway, I will go ahead and sign off there. I'll say thank you, and I will see you next time. Bye for now.